All right, so here we are with scale factor and dilations. This will be lesson 6 in your notes. All right, so Harold and his friends went to the wizard camp, etc., etc. Potions about growing and shrinking. So which ones grow, which ones shrink. So really all we're doing here is comparing the initial height of each of these, all right, to the final height. And you're just going to say, did it grow or shrink? Okay. All right, so potion 1, it looks like it decreased or shrank. Potion 2 went from 30 to 75, so that was an increase. All right, potion 3 went from 75 to 15, that's a decrease. And potion 4 went from 15 to 40, that's an increase. Let's answer some questions about this. Which scale factors made Harold grow? So if we look at the two that increased, we have 2.5 and we have 8/3. Okay, now 8/3 as a decimal is going to be 2.67, or 2 2/3 as a fraction. Okay, so which scale factors made Harold grow? And that would be 2.5 and 2.67. Which scale factors made Harold shrink? We have 1/2, so that's 0.5, and we have 0.2. So what do you notice about the difference in the scale factors listed in A and B? So in those two questions, the ones that made him grow were bigger than 1. Right? And then the ones that made him shrink, okay, were smaller than 1. All right. Predict what would happen if someone drank a potion scale factor of 1 itself, and they would stay the same. Remember, when you multiply a number by 1, it stays the same. Okay. Set up and simplify a ratio of the new height over the initial height for each potion. So the new height on top, the initial height on the bottom. And let's take a look at that. So for potion 1, we have 30 is the new height and 60 is the original height. So 30 over 60. If I reduce that, I get 1/2, which happened to be my scale factor. For potion 2, my new height is 75. Okay, and my initial height is 30. Okay, so if I reduce that, I get 5/2. And 5 over 2 would also simplify to 2.5. Same as my scale factor. For potion 3, I have 15 over 75. Okay, and that gives me 1/5. Okay, 1/5 in the calculator actually gives me 0.2, which is the same as my scale factor. And on the last one there, I have 40 over 15. So they're both reducible by 8, so that would give me 5/3, which we already said, 8/3, sorry. Okay, which they said will give me 2 2/3. Okay. Which is what I already had. Okay. So the connection there would be that it doesn't matter what the original height and the new height are, they're always going to reduce to the same fraction that you already have for your scale factor. All right, let's take a look here at a couple definitions. Scale factor is a ratio. Remember, a ratio is just a fancy name for a fraction. All right, of corresponding sides in a figure. So we really got to make sure here corresponding sides is a key word there. Okay, they have to be the sides that correspond to each other. If the scale factor is greater than 1, it makes the figure bigger. If it's less than 1, it makes it smaller. All right, so dilations are transformations that either increase or decrease the size of original figure. All right, and to dilate a figure, we multiply it by the dimensions by whatever the scale factor is. So it's not a real difficult process. All right, but it is really important when it comes to similar figures and congruent figures, which is a geometry topic. That's why we're learning about it right now. So let's take a look at an example here where you actually have to do some calculating, and then I'm going to have you work on a couple on your own. All right, so for this first one, we have a scale factor of 2/5. We want to learn the dimensions of the new rectangle. Well, first of all, the scale factor of 2/5 is smaller than 1, so it's going to make this rectangle smaller. Okay, it's going to be 2/5 of the size that it is now. All right, how do I figure out what those numbers are? Well, I take the numbers I have and I multiply them by 2/5. So I'm going to take 15 times 2/5. And when I do that, I get 6. All right, and then I'm going to take 35 times 2/5. If you have to use a calculator, there's nothing wrong with that. Okay, when I do that, I get 14. So my new shape, okay, is going to be 6 by 14. All right, so I want you to go ahead and practice that with these next few problems. Okay, the rest of these on the page. And go ahead and push pause and then come back. All right, so here we go. So the second one here, scale factor 3.5. So that should make the shape larger, right? 3.5 is a number bigger than 1. So I'm going to multiply my two dimensions by 3.5. So 10 times 3.5 is 35. 22 times 3.5 is 77. I end up with the new dimensions of 35 by 77. Second one here is 5/3. If you need to type that into a calculator, you can, but 5/3, the number on top is bigger than the number on the bottom. Okay, it's actually 1 2/3. So it should make my rectangle larger. All right, so let's see how it works. All right, 30 times 5/3 is 50. 9 times 5/3 is 15. So my new shape is 50 by 15. All right, now on to these next few problems here. Okay, so what I want to look at here is I'm trying to find the scale factor now. I have the original, the pre-image, all right, GHI, and I'm trying to figure out what the image GHI is. Okay, so I want to figure out what that scale factor would be. So remember, it's always the new over the original. So the 10 is on top and the 8 is on the bottom. That reduces to 5/4. All right, and does that hold true? Yes, 5/4 is 1.25. It's a number bigger than 1. It made my shape larger. What about number 5? Okay, clearly it looks smaller, right? So I'm always going to take my image over my pre-image. So I'm going to do 12 over 18, right? I can't do 8 over 12 because they're not corresponding sides. All right, now I know it's a rectangle, even though it's not labeled as such, okay, but it looks like a rectangle. But I want you to recognize the fact that YZ, all right, can only be compared to YZ, right? So we can't use the 8 here, okay, but we can use the 18 and the 12. All right, so 12 over 18 reduces to 2 over 3. And that makes sense because it got smaller. All right, the square below shows a repetition of dilation performed during design process of a bathroom remodel. All right, so on and so forth. Okay, so Mira, all right, is claiming, okay, that this is not a reasonable scale factor, okay, and she's right, okay, because the number 4/7 would actually make this figure smaller, not larger, okay, so 7/4 would have been the better option, okay. Last year we have Jess designing a custom rug. All right, so there's a couple things you got to know here. First of all, the customer wants the rug to be larger. Okay, so right away I went through and crossed out option B and option C because they're both numbers smaller than 1, which would make the carpet smaller. All right, and then I went through and I figured out what each of these scale factors were going to be. Okay, so I took 8 times 1.2 and I got 9.6 for letter A. That works. I took 8 times 2 and I got 16, which is too big, right? Because they don't want it to exceed 12 feet. So that one's no good. All right, and then last I had 8 times 1.5, and that gave me 12 exactly, so that's not exceeding 12. So that would have worked. So A or E would have been appropriate options there. All right, so hopefully you copy those notes down in your packet, and I'll see you in class.